Hello and welcome everyone. And in this short video, I am trying to discuss with you about the waterproofing of overhead water tank and the treatment of expansion joint and then damp proofing of plinth. That will be under the title of damp proof course. So let us start discussing about the waterproofing procedures in overhead water tanks. So basically, just like we have seen, the steps are almost similar in this case also. And first of all, we have to do the preparation work, and that is done by the chisels or the simple tools by which we remove the extra concrete mortar lying in the tank, and particularly from the corners around the chambers. And after collecting all the debris, we have to clean the entire tank along with the bottom slab and side walls also, and throw away all the debris. Okay, and then we apply the cement slurry. Okay, so that the applied cement slurry could fill all the holes and cracks which may be available in the bottom slab. So we apply cement slurry, and of course we add waterproofing compounds also in the cement slurry, and then we check the hacking of vertical walls from inside for better bonding with waterproofing. So basically we apply waterproof materials or the paint on the side walls or the vertical walls also for better bonding with waterproofing materials. So here you are seeing the diagram of a overhead water tank, and you are seeing many valves here. So let me discuss all the valves one by one. Many directions printed here are not exactly as per the mark, but this is wash out valve. Okay, so you can read all the notations from here index. This valve represents wash out valve through which the entire tank is cleaned. Okay, I have discussed about the wash out valve also, which is also known as flush valve. Then this valve is called the outlet valve. Now when the tank is filled, this valve will be used for the distribution of water. Okay, so this is outlet valve or outlet pipe. Now this pipe or this valve is again overflow pipe. Now when the tank will be filled up to the brim, so the water will start overflowing from this level. And fourth is the inlet valve. This is fourth, and it is the inlet valve. Now the level of inlet valve is always higher than the level of overflow valve. Okay, so you can do a small comparison here by drawing this diagram, and you can check the difference in the level. Okay, so this is the inlet pipe, and this black colored thick layer which you are seeing on the vertical walls as well as the base slab represents the smooth cement finishing with waterproof compound added in it. And then this sixth which you are seeing is the simple RCC slab with no waterproofing compound added as such, because there is no water on the top slab, because in a bottle the cap is at the top and the cap is always dry, isn't it? So there is no waterproofing is done on the roof slab. Okay, this is the roof slab of the water tank. Now this you are seeing is the brickbat coba. Okay, this is done on the roof, above the roof, because the roof is subjected to the rains. And above the brickbat coba we also do waterproof finish also. So this is the layer 8, and this we also do with providing a slope. So you are seeing the slopes on the top of the tank. You are seeing this slope. Okay, and you must be seeing a slope at the base of the tank also. You see this slope in the base slab. Why this slope is provided? Towards the flush valve or wash out valve, so that the water could get clean very easily when we are going for cleaning purposes. So this is about the overhead water tank, and in this we also check the inlet, outlet and wash out pipes for their rigidity. Now many times you must have witnessed the tanks in which the rigidity is missing at the connections of the pipes with the tank, and that is the potential point of leakage. And if the pipes are not rigid, grout them to achieve the desired fixity. So here is something we have to be extra careful. And before grouting, check the levels of these pipes, and if necessary correct them by sifting the pipes accordingly. Okay, after waterproofing plaster in cement mortar 1:4, means adding of waterproofing compound in the cement mortar plaster, by adding these compounds we apply 15 to 20 mm thick over this plaster, particularly on the corners and base slab, for avoiding shrinkage and to achieve better strength. Okay, the bottom of the top slab does not require waterproofing, so this is very easy. As we discussed, the cap of the bottle always remain dry, so the bottom of top slab require no waterproofing. The top of the overhead water tank is to be finished with brick bat coba, as mentioned for terrace waterproofing. Just like for home, terrace has to be waterproofed by using brick bat coba. Similarly for the overhead water tanks also, because they are overhead water tanks, so they are on the roof only, and the top slab of water tanks are like the terrace, so they have to be treated just like the terrace of the building. So we have to apply brick bat cover layer. After that we allow the waterproofing to set for at least 12 hours. Okay, and then we cure this waterproofing for a minimum of 15 days. So these are the diagrams of overhead water tanks, and something which you can guess from here whatever we have discussed. Okay, so let us discuss now something about the expansion joints waterproofing. Now expansion joints are not very common in normal residential buildings, but if we look at our college or some public buildings or some government complexes or malls, if you go in those large multi-story structures, you witness a gap after a certain stretch of building. Have you seen that? It is recommended that after 30-meter length of building we have to provide some expansion joints, and this expansion joint we all have studied in our physics is also provided and on the railway tracks also. So that this becomes also important for the buildings also, especially in earthquake regions. Expansion joint has to be provided for ductility also. Now expansion joint are the gap which is left deliberately in the structures, so we have to again treat the expansion joint, especially for waterproofing also, because from there also water can ingress inside the structures. Okay, because the gap is so less, it is very difficult to look inside or do plastering. Okay, so it is difficult to go inside the expansion joint, it is very less. And here first of all we do surface preparation for expansion joint waterproofing, and in that we clean the joint surface of dust, cement mortar, all things are removed, and remove oil and grease if they are from the surface. Protect the edges of the joint with masking tape. Now these are the materials which are used for treatment of expansion joint. Keep the tools like suspended scaffolding, ladder, spatula, putty knife, handheld gun equipments, etc. ready. So this was all about the surface preparation. Now you are seeing here expansion joint between two structure, isn't it? This is a concrete block and this is another concrete deck. and this is the expansion joint, and here we have done something filling material. Okay, and joint, all the things you can see, this is waterproof membrane applied here. So now let us discuss the work procedure for vertical expansion joint waterproofing. So first of all, primer is applied in the joint in accordance with the type of joint. First of all, primer, just like in the painting of any steel fabrication shop, you must have seen. First of all, primer is applied because primer is something which develops bond between the first material and the second material very easily. So for surface preparation, primer application is important, just like on the steel. So this is done on the concrete or the masonry. After the primer dries completely, sealant is prepared by mixing base and accelerator. Now mixing should continue till a uniform color is obtained. Do you see here a uniform color? Okay. So first of all, primer is applied and then this sealing is done. Okay. The base and accelerator are mixed in equal proportions by weight. Now there are two materials, one is the base and one is the accelerator. Accelerator is added inside the base so that it could settle or it could harden very fastly. Okay. So this mixed compound is then applied with a spatula or handheld gun equipment wherever required. Extra material is cut off with putty knife and a smooth vertical joint is created. So you can see this is a roller type of instrument. Now this uh, mixture is applied with a gun, you must have seen, and they use it for filling the expansion joint. And then you are seeing here the extra material is being removed with a putty knife. This is a simple steel flat and this is used to remove the extra material, and then the masking tape is then removed and surface is cleaned with suitable solvents. Okay, so this was about the waterproofing of expansion joints, and then let us discuss something about the damp proofing. And damp proofing is many a time misunderstood or misinterpreted as waterproofing. See, then waterproofing will become a misnomer. And for a civil engineer, we must know the difference between waterproofing and damp proofing. Now what we are going to discuss is damp proofing. And it is a simple one part or can be considered a part of waterproofing also. Because water is only coming in the form of damp here by the capillary actions. So dampness is the seepage of water through the members of the building. Now how water seeps? By the capillary actions, and there is very little difference between leakage and dampness, as there is very little difference between waterproofing and damp proofing. So if the water comes out of slab of the bathroom toilet, it is termed as leakage. Okay, and if it is observed on the external walls of the building directly exposed to rains and floors, then this percolation is termed as dampness. So one of the differences is written here, what is water leakage and what is dampness. So these are the pictures, and you must have witnessed such dampness in many of the homes in Dehradun also. And let us discuss how to do damp proof coursing. So basically in dampness what happens, the water is coming through the floors. Okay, why it is coming? Because the building load is ultimately getting transferred to the soil, and when we have not done the damp proofing course as such, then what happens, through the soil, actually the load coming through the structure on the soil is so much that it increases the pore water pressure, and the water inside the soil wants to come out through the weaker sections, weaker portions. Now we have made our building over the soil, so how will it come? So it will try to come through the porous plinth or RCC members. Okay, so the coming of ingress of dampness through the porous concrete occurs by the phenomena of capillaries. Okay, by capillaries water start rising, and then the pore water pressure consequently decreases. So that's why it becomes very common everywhere, especially on the ground floors. Now if we try to patch up or cover up the dampness by using tiles or using any kind of covering materials, it is not covered so easily because water wants to come out. And even if we provide the tiles up to the level of dampness, the dampness again rises and it comes out and becomes very evident to the eyes, and it really makes the environment unclean and aesthetics. Okay, so that's why damp proofing it becomes very important, and we use a damp proof course material basically on the plinth. Okay, and I will show you in the video at the end how the damp proof course is being applied on the plinths. Now first of all, as you see in this diagram, here it is a diagram level of the plinth here being shown here, and this is the soil level, and over the soil we provide a layer of plain cement concrete, and above that here we have used rubble masonry. Now rubble masonry is made of stone, and you can understand we use bricks also normal, and then we provide DPC. This is DPC. DPC means damp proof course. Now DPC material is used to avoid the dampness which is coming through the soil through the capillary action. So this DPC is applied on the level of plinth. So this level which you are seeing from where our structure begins, okay, this is the level of plinth, and from here is the level of our ground floor. At the level of plinth and the rubble masonry we have to do this damp proofing course application. Okay, so first of all, foundation masonry is kept in contact with the subsoil, which sometimes may contain water. Many times subsoil is having a sufficient amount of water, and the subsoil water tries to enter the building through the walls and floors. Not just the vertical walls, even the floors may be the source of this dampness. So we may have to do this damp proofing course below the floors also. And due to capillary action, the subsoil water sometimes rises into the walls of the building against gravity. Now this capillary action do something very wondrous, and people are startled. What happens? The water rise against the direction of gravity. This is the amazing action. I hope you must have observed capillary. Even in the case of if you pour a small pipe in the juice bottles. So generally foundation masonry is done with UCR masonry, and at the plinth level DPC is provided to prevent capillary water of the subsoil water. So when we apply this DPC, the capillary action of water is stopped, because DPC layer itself is impervious and it acts as a barrier for the trespassing water through the capillary action. And the rich cement concrete, generally of M20 grade with waterproofing compound added to it, can be used as DPC in buildings. Tar is also applied below DPC. So this tar or the bitumen which we used in the construction of roads is also applied below the level of application of DPC. Why it is done? To prevent the entry through capillary action. So the use of tar and bitumen provides an additional advantage when it is used in combo with DPC. Now above DPC, regular masonry for superstructure can be done, and we can be ensured of the damp proofing in our structure. So many a time people are in hurry, and workers are in hurry, and constructors are in hurry, and they escape this simple process or do it with simple compounds, and in long run people living inside the home suffers because of dampness. So this is something which has to be done by every person, and nowadays this is in trend, and there are sufficient varieties of waterproofing compounds available in the market that can be used for DPC.
This video shows the procedure of laying damp-proof course. The surface on which the damp-proof course is laid shall be thoroughly cleaned and wetted before starting the work. Cement concrete of 1:1.5:3 proportions along with suitable waterproofing compound in recommended dosage shall be mixed. The concrete has to be laid to a minimum thickness of 25 mm on the surface. After hardening of the concrete layer, a thin layer of Seal and Dry, which is a cement-based waterproofing compound from Ultratech or any other similar material, has to be applied in 2 coats perpendicular to each other with a gap of 4 hours between the coats. For application of Seal and Dry, you may refer to our video on waterproofing. The damp-proof course shall be laid to the full width of the walls and the edges shall be straight, even and truly vertical. The DPC should be laid at such a height that it is above the normal level to which water splashes from the ground when it is raining. The level at which the DPC starts should be minimum 15 centimeters above the highest ground level. The dampness creates unhygienic conditions in the building and also reduces the strength of structural components. Damp-proof courses prevents the moisture rising up the walls from the ground. Provide a damp-proof course between the source of dampness and the part of building adjacent to it. Damp-proof course should cover the full width of walls.
So I hope this was all about the damp proofing course on the plinth, and we will be discussing more on damp proofing in the upcoming videos also. So till that, stay tuned and stay safe. Thank you.